Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and try to solve it together. So today's challenge is a very simple one, both easy to understand as well as easy to code, and if you can find the observation, then it becomes really easy. Okay, so we are told to count collisions on a road. There are n cars in an infinitely long road. The cars are numbered from 0 to n minus 1 from left to right. Okay, and you will be given string directions, and the car can be in 3 states. It can be moving left, can be moving right, or it can be stationary, denoted by L, R or S, and then each car also has the same speed. You need to count the number of collisions. Each moving car can collide by one, and stationary car, if they collide with a moving car, uh, the stationary car's contribution is not counted. But if two moving cars collide, when two cars moving the opposite direction collide with each other, then the number of collisions increases by 2. That is, each of the moving car will get increased by 2. Okay, when the moving car collides with the stationary car, the number of collision increased by 1. So you can easily understand, find the number of collisions. So you can easily understand one thing, is that the number of collisions, so moving cars, they contribute 1 to the collision. Stationary cars, okay, stationary cars, they contribute 0 to the collision. How? As because two moving cars, if they collide, we will count it as 2. If one moving car and a stationary car collides, we count it as 1. And definitely if two stationary cars are there, they will obviously never collide, and we will count it as 0. So you need to count the total number of collisions. So if you try to see the problem at first, and a very cool observation can come to your mind is that, see, you are given some cars like this, okay, on a number line. The cars are something like this. Some are moving left, some are moving, let's say this is left, this is, let's say, right, this is left, this is, let's say, stationary, and then let's say this is right, and so on. Okay, let's say this also goes left and this is going right. Okay, so one thing is sure that in your whole array, the some parts of the array, so like if you consider the leftmost part, there are two cars which are moving at the left, and no matter what car is there inside that, in the front of that, they can never collide with each other. So you can call them outward moving car. Okay, outward moving. Similarly, if there is any car on the right which is moving right, this is also outward moving, and no car can actually collide with each other. I hope you can at least understand this much, right? So you see, I define outward moving car as the cars which is going left, okay, and it is present on the left, okay, which is going left and present on the left, and another outward moving car as something which is present on the right and going right. So since all the cars has constant speed, no, these cars will just move out with each other, and even though moving, they won't contribute anything to the collision. No contribution to the collision. So we need to separate them out. Okay, and in between, how many cars are there? If they are moving, they contribute 1. Okay, so you can just add all of them. So you see, it is very simple. So let's say this is L, L, R, L, this is stationary, this is, let's say, R, and this is R. Okay, this is not R. Okay, so this will be left, and this is R. So you see, these two were the outward moving car, so I just ignore them. This R is also the outward moving car, so I ignore them. And in between, all the moving cars, they contribute 1 to the collision, no matter what, no matter how they collide, no matter what is the nature of collision. The moving cars do always contribute 1 to the collision, right? So you see, this R and L, they will contribute 1, this will contribute 1, this stationary car will contribute 0 to the collision, this moving car is there, so 1. So total of 3 collisions in this case, and I guess in this way you can easily find that out, and that is very simple. How we will solve this in terms of coding? You can keep one left pointer and one right pointer. You can initialize the left to 0 and right to n minus 1. What you can do is that keep iterating while L is less than n, and while this direction of L is equal to capital L. So while this is L, you just keep shifting R. So one place you will be shifted L equals to 2 over here, and from R minus 1 you keep on doing R minus minus whenever you see an R. Okay, so you will see that the R is over here, n minus 1. So 2, 3, 4, 5, 5. Okay, so now you keep a I pointer which will go to which will iterate through this L and R. Okay, I is less than equal to R, I plus plus. You keep an I pointer and you just iterate through this L to R, and you check whichever is not S, I will have 1 to my contribution and return that as the answer. I hope that is very simple, right? Approach and intuition and everything, I guess it's very simple and very clear. Only the observation is required that outward moving material they do not contribute, and all the other vehicle they just will contribute to one, no matter what is the nature of collision, how exactly they collide, it doesn't matter. So I hope it is very simple and things are not complicated at all, and you can just quickly choose to code that out. You have got L equals to 0, R equals to n minus 1, while L is less than n, and directions of L is equal to capital L, right? What you can do, you can choose to do L plus plus, and similarly for R you can do while this right pointer, you see right pointer you are moving backwards. Okay, so while it is greater than L, you can write this. Okay, so while it is greater than L and directions of R is equals to R. Okay, can I call it greater than or equal to L? Let's say all the pointers are something like this. Let's say this is L, 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 and there is a stationary, there is another L, R, R, R. So I pointer will be stopping at this position, and right pointer will be stopping at this position, right? What if this was not there? Anyways, they would have contributed to 0. So yeah, no matter what you do, it will just work fine, I guess. And R minus minus. Okay, so you have this, you move your L left and right pointer, and answer you have 0. And what you can do is very simple. From I you can traverse from L to R. So I less than equals to R, I plus plus, and if directions of I is not this S, okay, if it is not S, then you add 1 to your answer. Okay, no matter how they collide, they will always contribute 1 to the answer and return answer. I hope this is very much simple and just 10 lines of code. Let's see, let's try to submit and check if there is any error. Okay, so I am initializing this, right? Yeah, so okay, so we are getting a wrong answer over here, LLRR, and the output is 1. So I guess this should be necessary for this. Let's see. Yeah, we get the accepted thing. If we try to submit it and check, yeah, we do get the accepted, and it is a simple O of n solution, as well as the time complexity and memory are pretty decent. So I hope you did understand the method and the simple approach for today. Yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.